All right, we are starting ST3 today, which goes a little bit more into trig. So what we're doing is called inverse trig. Up until now, we use trig to find a missing side of a right triangle. Well, we can do what's called inverse trig to find the angle that was in that right triangle when we know a couple of sides. So the first thing I want you to do is to put this in two-page view, because if this was printed out, and don't click show cover page, if this was printed out, this would be back to back. So now you can see this sign -1 symbol next to these sign of AB letters. Okay, and then we're going to go through each of these. Okay, we're going to start with right here where it says sign to the -1. Now that's not how you read that. You read this as inverse sine. So what it does is it finds the angle in a relationship that has opposite over hypotenuse. Okay, the -1 is kind of risen like an exponent. It's kind of hard to see with that font. All right, so this is called inverse sine. So just like before, sine of angle A is opposite over hypotenuse. So it's little a over little c. All right, I'm not sure what the second set of lines are for, but now we're going to go ahead and put an O and an H, opposite over hypotenuse. And then when we're looking at sine of B, it's still opposite over hypotenuse, but in this case it's going to be little b over little c. Okay, so that's all the same as before. So here in this first one with the 17 and the 12 is the, stop doing that, it's the opposite, and the 17 is the hypotenuse. Okay? But except this time we are trying to find the angle x. So we already have the two sides, we're trying to find the angle. So I'm going to start you out just like we did before. Sine of theta equals opposite over hypotenuse. Now when we invert that, we're trying to find the theta. So the inverse equation is inverse sine of opposite over hypotenuse equals theta. And then we're going to plug in what everything what all the letters mean except for the theta. So inverse sine of 12 divided by 17 equals our angle. And that at that point it's solved for the unknown, which is like when we solved for x. So we're going to plug that into our calculator. Our very, very small calculator. Okay, so then we're going to do second sine. See how it comes up with the little inverse symbol? 12 over 17, close that parentheses, oops, wrong one, and enter. I did it again. I'm in radian mode. This is not going to work, so I got to go to mode. Super frustrating. Okay, second quit. All right, so now I'm going to go up and I'm going to re-enter that data and watch me get a different answer now that I'm in degrees. So our angle measure is 44.9. Not theta, x equals 44.9 degrees. 44.9 degrees. Okay, let's try this other one with the 3 and the 7. Inverse sine of opposite over hypotenuse equals theta. So inverse sine of 3 over 7 equals x. And that is what you type in. Inverse sine, 3 divided by 7, and you get 25.38. Or 25.4, depends on what you're rounding to. We'll do tenths. 25.4 degrees. Okay, so that's how you use trig to find the missing angle. You have to have at least two sides, and you can find the angle. Okay, inverse cosine is going to be the exact same thing, except it's going to be adjacent over hypotenuse. So cosine of A is adjacent over hypotenuse. So that's going to be little b over little c. And cosine of B is going to be little a over c. Remember, adjacent is the side that touches the angle after you have eliminated c being the hypotenuse. Okay, so this equation is just slightly different. Inverse cosine of adjacent over hypotenuse equals the angle. So we're going to fill it in. The adjacent side is 5 and the hypotenuse side is 9. Remember, the hypotenuse doesn't touch the right angle. And the unknown angle is x. So I'm going to type that in. Inverse cosine. Don't forget to press that second first. You got to see the -1 of 5 over 9. 56.3 degrees. Okay, then we have inverse cosine of adjacent over hypotenuse equals theta. Inverse cosine of 20 over 38 equals x. And yes, you have to write that -1 every single time. If you don't, then we're doing regular cosine and we're trying to find a side. So we've got inverse cosine of adjacent over, 20 adjacent over hypotenuse, 38, and we get 58.2 degrees. Okay, last one is tangent. Works exactly the same way, except we're going to do opposite, tangetoa, yes, opposite over adjacent, SOHCAHTOA. So you still use that to remember. Opposite over adjacent, opposite over adjacent. So tangent of A is A over B. Tangent of angle B is B over A. The equation is inverse tangent of opposite over adjacent equals the angle. So inverse tangent of 5 over 12 equals x. Second tangent, 5 divided by 12, x equals 22.6 degrees. Okay, super easy, right? It's almost easier than finding the side because there's no division involved. Okay, so our last one, inverse tangent of opposite over adjacent equals theta. So inverse tangent of 9 over 2 equals the angle. And we're going to type that into our calculator. So inverse tangent of 9 divided by 2, 77.5 degrees. Degrees. All right, so this is what your assignment for today looks like. It's all inverse trig, just like we practiced in the notes. So I'll do the first one with you. You've got hypotenuse, and you've got opposite here. And this would be adjacent, but we don't have anything with adjacent. So it's going to be O and H, which is sine. And we're trying to find the angle. So it's inverse sine is O over H equals theta, as opposed to the other one, which was sine of theta equals O over H. So the inverse sine of 12 over 21, type that into your calculator, and you're going to get your question mark. Now, look below. It should be one of those numbers there. So if you are getting an answer that is not one of the numbers at the bottom, you've done something incorrect. And the directions say round to the nearest degree. So that should help you there. All right, if you have any questions, bring them to the meet at the last 10 minutes of class.